What's up, guys? It's Chase from Chase's Workshop, and in this video we're going to be building a Gauss meter just like this right here. And in the next video I do is basically me trying to figure out how to put all this crap into a box. Guys, I hope you enjoy the video. If you do, give me a like. If you like it, please subscribe. Thanks for watching. Well, alright guys, so here I've got the circuit out set up for you. If you hadn't seen where I got the schematics from, if you didn't see my live stream, I got all the information from this from rimstar.org to build this section right here of the what I've got on the breadboard here. It's very simple. This comparator is a little tough, but with everything that I've got set up now, you do not need the comparator to run any of this thing once we get it using Arduino, because I got the Arduino doing all the calculations of if it's north polarity, south polarity, and all that kind of stuff. So what we're going to go through first is, and I'll leave a link in the description too where you can go find the schematics for this on rimstar.org, and it's they've got a very good article on it if you want to check it out too, and a lot of information on it. Now there's basically 4 sections right now, but like I said, we're only going to use 3. We're going to use everything but this comparator when we actually put this thing into a box, and it's very simple without that in there. Now the first section is this section between my fingers here, and this is all it is a voltage 5-volt voltage regulator. I've got 9 volts coming right here. I've got a positive 9 volts here, and I've got my ground right here. So this is my ground bus bar, and this is my positive up here. And all this is doing, this is a LM7805, and it's regulating the 9 volts down to exactly 5 volts. And these do a great job of keeping it at 5 volts, depending on whatever your input voltage is. It's basically going to keep it at around as close as possible to 5 volts. And they do a really good job of that. And that's basically all that is, and it's a very simple circuit, very easy to do. This right here is our Hall effect sensor circuit, and it's very similar to this voltage regulator. It's basically the same thing. The only difference is this Hall effect sensor right here is either allowing voltage to flow through or restricting voltage, depending on what strength magnet you put in front of it. So that's basically all it is, and then it's sending that out on this orange wire right here and this blue wire. I've got 2 different parts because I got one going to this comparator. And all the comparator does is when you put a magnet in front of it, it tells you whether it's a north polarity or south polarity. That's all it does. So if I take this magnet right here and I put it in front of this sensor right here, as you can tell, my red LED come on. I don't know if you can see it good or not in the video, but my red LED come on, and that means it's north polarity. If you look on my readout here on my LCD, I've got it saying north here. Now if I flip it and go the other way with it, you can see the green LED come on, and my Arduino says south, and it's giving me a Gauss reading here. So I'm doing all those calculations in Arduino, and that's why I'm going to be getting rid of this whole circuit right here, and you don't need that in here. Now if you look at the schematics on rimstar.org, where this wire right here, this blue wire right here, on their schematics, this comes off and goes to a cheap digital volt meter basically, and they've got it pinned to the front of a mint box, I think is what it was. Instead of that going to voltage meter, I've got it going to a voltage sensor made for the Arduinos. And so basically this thing here is reading the voltage that Hall effect sensor is sending out, and then sending it to the Arduino where we can do calculations with it. Now when I got this component here, and the first thing I always do when I get a new component with Arduino is I go to RoboJack's channel, and I'll leave a link in the description where you can go check it out, this video and then his channel too. So if you enjoy doing Arduino stuff, he does a very good job of explaining all of it, and gives you the code to get it up and running and everything. So majority of the code that I'm going to show you here shortly is from him, but he goes through hooking this guy up, setting it up, calibrating it and everything, and it's very easy to do. And so like I said, this is coming to this voltage sensor, which is sending all our information to our Arduino board, and Arduino is doing all our calculations here and printing them out on this LCD. So and it's very simple to hook up. I'm going to go through hooking all the Arduino and stuff up too. Like I said, the blue wire comes off, goes to the positive on our voltage sensor, and then our negative just jumps off and goes to our ground bar right here, to our 9-volt ground right there. And then on the other side of our voltage sensor, you can see we've got two pins hooked up. You've got 3 different pins. You got a S, a plus, and a minus right there. Maybe my light where maybe you can see it better. You got a S, a plus, and a minus right here. The plus is not hooked up. The S is the red wire. It comes off and goes to analog 0 right here, or A0 on our nano board. And then the minus right there just goes to ground on our Arduino board. Right there. Got to go on the ground. And that's hooked up. It's done. Now this LCD screen is actually LCD screen. It's LCD IC2 screen. I'm going to put a link to all these parts in the description where you can go down there and get one if you want to. But I would highly recommend getting one with the IC2 backpack on it to where you can, it's a lot easier to hook up to your Arduino than trying to do it with just LCD screen itself. Now, these parts are a little more expensive than these. These are dirt cheap. I think I bought 5 of these for, I'll put them in the description, but it's not very much at all. And these are a little more expensive, maybe 2 of these for $10 or somewhere around in there. But anyways, there's 4 pins on the back of this guy. I'm going to try to get it to where you can see it. Okay, so we've got 4 pins. We've got ground, voltage, data, our SDA, and serial clock, our SCL right here. Now ground, of course, goes to ground on the Arduino, or I just got it grounded out to 9-volt ground right here. And then the red is the VCC, taking 5 volts off of our Arduino on the red right there. Right there, 5 volts. The SDA, which is the yellow, is going to A4 right there. And then the SCL is green, it's going to A5. And this guy's hooked up. Now, as far as wiring up the Arduino itself, all I've done is I've just taken make sure you go to the voltage in right there, the VIN right there, and run it to the 9 volts, and this thing will regulate the 9 volts down to power this. And then you just need to run the ground from the ground pin here to the ground on our 9 volts and complete the circuit. So that's all there is to hooking this thing up. Now, one thing I want to cover right quick on this LCD screen is, one thing I want to cover with this is that if you first cut this thing on and you get this right here, when you cut it on, don't get discouraged. It's probably just you need to adjust this potentiometer on the back to make the screen a little bit to where it can show all the readings and stuff on it. As you can see there, it's coming back. Adjust it up a little bit more, a little too much. There's a fine spot in there, but as you can see now, you can see everything on there. And that's basically it for all the components. Like I said, these first 2 parts here are very simple to build. This comparator, which we don't need, is a little more difficult to build, but I'm gonna, here in a minute, by the end of this video, I'm gonna have this out and I'll go through everything again, where it's not as cluttered as much. But next, what I want to do is I want to go over the code for this thing, because there's a couple things that I need to go over with you on it about adjusting this voltage sensor and setting up this LCD screen. So stand by, guys. Well, all right, guys, so here's our code. This is everything that I've got that I've put together to make this thing work. Now, I got the majority of this code from RoboJax, and that was mostly the code for the voltage sensor, and I got some of the liquid crystal I2C code from another website where I kind of just pieced it together to get it to this point here to where it would work. Now, I'm going to have all this code in on my Google Drive, where you can get on there and you can download it, and basically all you do is copy and paste it into your Arduino IDE, and you won't have any problems with that. Now, the first thing we've got to do, though, is we've got to get this liquid crystal I2C.h library. And I've got a link in the description where you can find the website for that, and it's going to take you to this page right here. Now, when you go there, it might be a different file than the new liquid crystal 1.5.1 zip. It might be something else, but just click on the newest one, download it, and once you download it, it'll be in your download files, and then you can go to there, and it'll be in here as a zip file. Once you get in there, right click on it, you can go to extract all, and it's going to ask you to browse. When you browse, go to your computer, go to local disk C, go down to mine's program files x86, whichever one your Arduino's in. It's probably going to be in this one. Click on that. You'll see Arduino right here. Once you click on the Arduino, go down to libraries right there and then click OK, and it'll extract all of those files into your libraries for your Arduino IDE. And now at that point you can use this code and it will work with your it will all work. It won't give you any errors or anything like that. Now, the other thing you need to check right quick, and you probably won't have to do this. I didn't have to do it, but I checked it anyway just to make sure, and I wanted to give you guys the ability to check it yourself if you needed to. Now, this LCD screen and the Arduino have to communicate with each other, and they use a path. They use it's almost like just a path, and whatever that path is can be different between different Arduinos and different screens and stuff like that. So if you're having trouble getting this thing to work together, you might want to check this out and see what it is. Now what it is, if you look right here on the code, this 0 by 27 right here, that's basically the path that the Arduino knows to check with the LCD screen to communicate with each other by using this backpack that we have on this thing. Now, if you're loading this up and you're not getting anything on the screen, here's a fix you can do to find it. And what you need to do is go to back to my Google Drive, and I'm going to have a link to this code here too. And basically what you'll do is you'll take this code right here, it's an I2C scanner, and copy this code into a Arduino file or an Arduino IDE file, upload it to your Arduino, and then open your serial monitor. And to do that, you just go to Tools, Serial Monitor right here. And once you open it, it's going to run the scan, and it's going to give you a reading, and it might say 0 by 27, it might say something else. Well, whatever it says right there is what you need to enter into this spot right here, the 0 by 27 right here. And once that's in there, it should communicate and there shouldn't be any problems. But like I said, I didn't have to do this, but I'm just giving you an idea to where if you're having issues getting yours up and running and it's not working, this might be what's wrong with it. And like I said in the previous part of this, make sure the LCD screen is set to a brightness that you can actually see the numbers and stuff like that on it. So basically all this code right here, everything you see pretty much I got from RoboJax. Everything to about here I did. I got this part right here from another file and all that good stuff. But this right here is basically all I did to it. Was I added this integer of Gauss, and then I added in these calculations right here. I changed up the delay a little bit and got this thing to where we can use it for what we're doing. And all this is doing, I set an integer for Gauss, and I put Gauss is equal to our voltage minus 2.5. Now, if you didn't see my video, my live stream I did, basically the way this thing reads is you have 0 to 5 volts is our measuring range. Now, the Hall effect sensor is going to give you 2.5 volts all the time. It's not going to go above 2.5 or below 2.5. It's going to be somewhere right there in the middle is where it starts at. Now, if this thing is a south polarity magnet, it's going to go positive of that 2.5. So it might go to 3.5. Well, we don't need the difference of, we don't need to take the 3.5 and multiply it. We need to take the difference between 2.5 and 3.5, which would be 1, and multiply that by our conversion. And our conversion is 1 volt equals 1300 Gauss. So I'm taking the voltage, which, just say for instance, say the voltage is 3.5. I'm minusing 2.5, which equals 1. 1 volt difference between the two, and then I'm multiplying that by 1300. So that would give us a Gauss reading of 1300. And the same thing with if it's below 2.5, it's going to subtract 2.5, give you the difference that way, and it's going to be a negative number at that point, and whatever that negative number is, it's going to multiply it by 1300 and give you a negative number for our Gauss. And then this right here is just setting up the LCD screen. This is just so it prints Gauss on there where you can read it. And then this one is actually taking the value of Gauss right here and putting it on the screen where you can read it. And then this is printing out the voltage, whatever the voltage is. And then this is actually this is actually how I'm getting the, if it's north polarity or south polarity, and it's just a if statement. If the voltage is less than 2.5, LCD print north. else print south. So it's going to give you a reading all the time, even with nothing in front of it. Might say south, it might say north, or whatever, and it kind of varies. It doesn't always just stay at 2.5 volts. Sometimes it varies to 2.48, and it might go up to 2.52, but it's right there in that range, so it's close. And it's probably not as accurate as a $200 Gauss meter, but for as cheap as it is, and it kind of gives you a basis point to start with, hopefully. But anyways, and then all I do is I give it a 4-second delay, and then I clear the LCD screen and restart this whole thing, and it just keeps repeating over and over and over and over again. Now, there is one other thing that you probably going to want to do, and that is to set up the offset. And it's not hard to do. If you look right here and you see this integer offset, I've got it set to 6 right now. And basically what that is with this thing set to 0, if I was to change this to 0 and cut this thing on, and in my voltage on the bottom left corner, it might say 2.48 instead of 2.5. Well, I want it to say 2.5, so I need to add 2 to that. So I would come in here and I'd put 0, 2 for that. And then when I put the program back, or when I upload it up to the Arduino, it's going to say 2.5 at that point. And mine was about 6 off. If it's positive, if you plug it up and it says 2.54, you'd want to put a negative 0.4 on there to get it to 2.5. And that's just all that's doing is calibrating the voltage sensor, and it's not very far off at 0. It might be 5 or 6 points off on that, but it's not much. And I'll show you here in just a minute what I'm talking about on that, to where you can see it better. But that's basically it for the code. If you have any questions about any of this stuff, guys, seriously, just send me a comment and ask me about it or whatever. If I need to do another video, I will, or whatever. I'm here to help you guys, so just let me know. Okay, guys, so what I want to show you right quick is I want to show you what I'm talking about with the offset. Now, if you look right here at the bottom, it says exactly 2.50, and that's our voltage that we have coming out of this guy right here. That's the voltage we got coming on this far left pin right here. Now, when I set this thing, if you remember, I had mine on here set to 0.6, basically is what that was. So that means that this was actually 2.44 was my reading on it. And you can tell now it's went up a little bit. So what I want to do is I'm going to go over here and I'm going to set that back to 0 and show you what I'm talking about. So I'm in the code right now, and I'm setting the integer offset to 0. And I'm going to upload it onto here and show you what I'm talking about. Okay, so when you cut yours on, this might be what you might see. And like I said, it's not very far off. Yours might be a little bit farther or whatever, but it's giving me, it's saying the center is 2.44. And so that's why I'll come on here and I added that 6 positive to this to get it up to 2.5. As you can tell, it just fluctuates. I don't think there's any way to get rid of that. But now I'm going to take it and change it back to the integer back to 0.6 and upload it again and show you what it does. And it should go pretty close to 2.5 volts. So at 2.52, so we're still above it, but it's been fluctuating between there. It might be a couple points off, but it's pretty close. It works out pretty good. So there's back to 2.5. So that's what I was talking about with that. And you don't necessarily, I guess, have to set that, but the best way to do it is the way I just showed you there, is to go to 0 on the file, and then see how many you're off, and then add that amount or subtract that amount in there. And just remember that if it's 0.44, don't put 0.06 on here, just put 0.6. And if you need to take off 6, put negative 0.6, and it'll adjust this to where it's centered and accurate. And that's basically it for that. All right, guys, so I've got everything back to where what we have in the circuit. I'm just going to go over these 2 circuits with you right quick. This first one here, the LM7805 voltage regulator, very simple. I got 9 volts coming in here, 9 volts going to the pin 1 on the LM7805. It's coming out of pin 1, going through a 100 NF capacitor right there, and then going to ground. Middle pin's going from the pin to ground, straight to ground, and then pin 3 is going through a 100 NF capacitor and going straight to ground. And the 100 NF capacitors, these little ceramic looking capacitors, and the number on them is 104 if you're trying to find one. I found that out. And then basically this coming off and going to our Hall effect sensor on pin 1 right here, and it's going through a 10K resistor to ground. The middle pin's going straight to ground, and the pin 3 is going it's going through a capacitor and then to ground, and then I'm pulling our voltage for our voltage sensor off of that before the capacitor there. So between the capacitor and that. And then I'm just got it going. I kind of pulled it out and put it on this to where I can show you how to get a reading off of this thing. Now, if you look at this sensor here, if you look at this Hall effect sensor, you can see the front. See how it's got 2 angled sides on it? You want to get a reading from this side right here. You don't want to get a reading from the top or the back. If you do the back, it's going to be the wrong polarity when you put it up there. You'll get a reading, but it'll be opposite of your polarities. And so when I do a reading here in just a minute, you'll see me. I'll lay this flat down onto the pickup. Now I found other calculations online, and I think a lot of it has to do with depending on what type Hall effect sensor you're using. And since we're using the one off rimstar.org, and this is one they call for, I'm going to use their conversions and everything to make it all right. So now what I want to do is I want to do one of these pickups that we built, the walnut pickup. I'm just going to try to get a reading off this thing and see how good it does. And one thing about this too, I know this Gauss meter is probably not near as accurate as a $200 Gauss meter, but as long as you use this same one on every pickup that you do, it's going to be accurate to you. You know, it doesn't really have to be accurate as exactly to what a Gauss is in order for it to be accurate for you building your own pickups and getting information from different ones and stuff like that. So that's what I think the biggest thing with this is. Now what I'm going to do is I'm going to take this thing, and if I hold it right up against it, I'm going to get a crazy reading. I'm going to get a real high reading off of it. So I'm getting 988. Now one thing that you want to do is you want to get, or I think you want to do is you want to get your Gauss reading about string height. So right now I'm about a little less than a quarter, maybe 3/16, between an eighth, somewhere around there off of it, just about where a string would be. And I'm getting a reading of 312 Gauss right there. Now I'm going to move it down. I'm going to get my next magnet and see what I got. So 221. It's staying right at 221. See what I got here. 247, 286, somewhere in there. Next one. 247. 247. And 312. 286, 312. 350. My hand's shaking a little bit too, so that might be what's making it do that. But you want this sensor too to be perfectly as level with the pickup as you can get it. That way, you know, you're getting accurate reading on every one of them. So now I know pretty much what the Gauss reading is on this guy here. If I take another pickup, this is one that I didn't build. This is one that I bought. I don't remember where I got it from, but we're going to do a reading off it and see what it says. Okay, so this one's north polarity, and 572 on the first one. Okay, I don't know why it's doing that. This must be like a really 507. Okay, 376. 507. This one's a little bit hotter. One thing I've learned, or that I've, when I've researched these things to see is that the more Gauss, the higher the Gauss, the brighter the pickup. And this being a tele bridge pickup, it probably has you want a high brightness on it. So there you go. That's basically it on these. And hopefully this makes sense, and hopefully that you can make something like this too, to where you have you're able to get a reading off your pickups now. Well, all right, guys, that's about it for this video. If you have any questions or comments, like I've said 1,000 times, please just leave them in the comments or send me an email or whatever. I want to help you guys out, and I want y'all to help me too. So if you have any comments or anything that I can do to make this better, let me know too. I'm brand new to this, so any of your help will be greatly appreciated. Guys, if you enjoyed the video, give me a like, and if you like it, please subscribe. Thanks for watching.